Hi everyone, welcome back to the EKS series. In the last episode, we explored load balancers and ingress and learned how we can allow external traffic to reach our application inside the cluster. Now it's time to talk about something equally important, the storage. In this video, we'll dive into persistent volume and persistent volume claim and learn how we can use it with AWS EFS and EBS. By the end of this video, you'll also understand how PVC and PVCs work. So let's get started. But before we start this video, if you haven't subscribed to the channel, please consider subscribing because it will motivate me to create more videos. So let's get started. We'll start by creating an EKS cluster, and if you don't know how to build an EKS cluster, I will recommend you to watch the first or the second episode of this series. So I'll fast forward this process so that we don't waste time on things that we have already done. Alright everyone, so our EKS cluster is created through CloudFormation. Now all I have to do is connect to this cluster. So as a part of this cluster or the CloudFormation template, a kubectl server is also provisioned, where we have installed Helm, EKSCTL and kubectl. So I'll just click here and I'll connect to the server using SSM Systems Manager. Okay, so I'm connected. I'll switch to sudo, and right now we will be running all our commands as sudo user. So before we connect to this cluster, we have to run a command which will create an entry in our kubeconfig file, and the command is AWS EKS update kubeconfig. You have to provide the name of the cluster, which is prod in our case, and the region where your cluster is running, which is AP South 1 in my case. Alright, so the entry is created in our kubeconfig file, and now I can run all my commands. But before that, I'll add an alias here. And now I can run my commands kubectl get nodes, and you will see there are two nodes which are provisioned for our EKS cluster. So now let's move forward, and for that I have created a GitHub repository specifically for this course. So I'll open this repository, and for this video we'll move to the second folder, which is called EBS and EFS. First of all, we'll click on this first folder, which is called install addon.md. So here we are going to create an IAM role which will be used by the EBS add-on. So what is an add-on in EKS cluster? So add-ons are basically the extensions which allow you to extend the functionality of your Kubernetes cluster. Alright, so I'll copy this entire command from here. I'll paste it in my notepad, and I have to make a few modifications before I can run this. Alright, so if you see here, I have to replace some part with the actual values, and for that I need the OIDC provider. So all you have to do is go to the IAM console, click on identity providers, and as a part of this CloudFormation template, the identity provider is already created. So all you have to do is just copy the ARN of this OIDC provider and paste it here. Alright, so this part is done, and if you see this part here which says string equals, you have to paste the OIDC provider here, which is here. So I'll copy this OIDC provider and I'll paste it here. Okay, this is done, and I have to do the same thing here as well. Alright, so now we're good to go. So now what I'll do is I'll just copy this entire script or this entire template. I'll head over to my kubectl server and I'll create a new file called trust policy.json. I'll paste the template here or the permission template here, and I'll now exit out of the Vim. So now we have this file here. Let's move to the next step, which is to create an IAM role with the above trust policy. So I'll copy this command from here and I'll paste it here. The moment I press enter or I try to run this command, I'll get an error, and I'll explain why we are getting this error. So here you see we are getting this error which says the user ARN AWS STS, this role is not allowed to run any of the IAM commands, and the reason for that is the cluster or the instance to which we have SSH'd in doesn't have permission to use IAM commands, and you can validate it from this IAM role which is attached to this instance. So I'll just open it in a new tab, and if you see here it has two permissions attached. One of them is the EKS permission and the other one is related to SSM. So now what I'll do is, for the sake of this video, I'll attach a new policy, and which is going to be the administrator access. I'll click on add permissions. Alright, so the role is modified. Now I'll again head over to my kubectl server and I'll again run the same command. So now you can see that our role is created, and the role is called Amazon EKS EBS ESI driver role. You can validate it from the console as well. Go to your IAM console, click on roles, paste the role name, and as you can see we have this role here. So right now this role is created, but it doesn't have any permissions, which you can see here. Now what we do is we are going to add permissions to this role, and for this we'll run this command. What does this command do? This command attach the managed policy to the role. And what is that policy? Well, it's an AWS managed policy which is already created by AWS. So all you have to do is just search for EBS and you will see this policy here which says Amazon EBS CSI driver policy. So I'll run this command here. Alright, so this policy is attached. Now if you go to the role that you created earlier, we call EBS CSI driver role, and you refresh it, you will see this policy is attached. Alright, so we're done up to this part. Now what we have to do is we have to install the EBS add-on on the cluster using the role created. So if I head over to my kubectl server and I run a command kubectl get pods in kube system namespace, you will see there's no pods which are running related to the EBS. As you can see, there are no pods running right now, and the moment we install the add-on, we'll have some pods pin up here. So now I have to go to my EKS cluster, select the cluster, and I have to go to this add-on tab here. Click on get more add-ons and select Amazon EBS CSI driver. Just click here, scroll to the bottom, click on next. Now we are going to use IAM roles for service accounts, and here you have to use the role that you created, which is this one. Click on next and click on create. Alright, so it says the add-on was successfully added to the cluster. And how we can verify that? Well, if we run the same command again, we'll see that there are two pods related to the EBS CSI controller, and if I just run it again, I'll see that the pods are in running state. Alright, so we are done up to this part. Now what we have to do is we have to create a storage class. In case you don't know what is a storage class, you can just search it in the Google, because it's an important concept. Kubernetes has a special dedicated documentation for this. In Kubernetes, you can just read it from here, or you can watch some YouTube videos. There are a bunch of videos which are related to storage classes. Okay, so let me just copy this part from here. I'll paste it in my notepad and I'll make few modifications. So I'll remove this part also, because it's optional. Encrypted, let it be true, because we want our EBS volume to be encrypted. Volume binding mode should we wait for first consumer, and for the type let it be GP3. So just copy this entire content, head over to your kubectl server and create a new file called EBS storage class.yaml, paste it here, and now just do kubectl apply. It says the storage class is created, and how you can verify that, just run kubectl get storage class and you will see that this storage class is created. Okay, now let's move to the next part. If you want, you can convert it to the default storage class, but I don't think I need it here. So now what I'll do is I'll create a PVC. I'll just open the Vim editor and I'll create EBS PVC.yaml. I'll paste it here, and now I'll apply this file as well. It says the PVC is unchanged. My bad, I think I misconfigured something here. Okay, I accidentally pasted the storage class content. I'll copy it properly from here. Now it's copied. I'll paste it here. And I'll apply this file. Okay, so our persistent volume claim is created. Now let's move to the next part, which is to create a deployment which will use this PVC. If you noticed, we did not create any persistent volume here. It's because the persistent volume creation will be dynamic, which means the moment we spin up a deployment, the pod will just refer to this PVC and dynamically provision a persistent volume. Alright, so let's just copy this command, this entire deployment file, create EBS deploy.yaml and paste it here. Just make sure your persistent volume claim, the claim name is correct here. Okay, and I can verify it from here. So if you see, the status is pending right now because the pending mode was wait for the first consumer. It means until and unless a pod is created and requests for a persistent volume, it will be in pending status. So now all I have to do is just apply the file, and now our pod is created. Just run this command kubectl get pods, and the pods are in container creating state. Alright, so our pods are up and running, and whether or not they are using the PV or PVC, we can verify it using the kubectl describe command. And if you see here, you will see this part called volumes and our EBS volume. And other way to verify it is through the AWS console. Just head over to console and go to the EC2 console, where you can search for the EBS volume which was dynamically provisioned. So if I go to volumes here, you will see that there are a bunch of volumes, out of which some of them are related to my EKS nodes and my kubectl server, but this one right here, the one which is of size 5 GB, was created dynamically by the pod. Alright, so we have created a pod which is using PV and PVC, but there's an issue with this, and the problem is EBS volumes have a few restrictions. The EBS volumes must reside in the same availability zone as your EC2 nodes, and that's a big concern because sometimes our pods might be created in some other nodes which are in some other AZs, and when that happens, the pods won't be able to use the PV, and that is a huge concern which is related to the persistent volumes when we use it with EBS. And to overcome this, we can use something called EFS. So now instead of EBS, what we'll do is we'll use EFS, and that too using dynamic configuration. So what I'll do is I'll just go back one level. I will open this file called efs.md, and now we'll repeat the same instructions or the same steps that we did for the EBS, but now this time for the EFS. So what we will do is, first we'll create a role, and that role will be used by the add-on to dynamically provision the EFS volumes. So I'll just copy it, paste it here, and now we'll do the same stuff that we did earlier. I'll go to IAM. I think I'm already in IAM, so I'll just copy this identity providers ARN, and I will paste it here. Alright, and now I need to copy the OIDC provider, which is right here. Okay, so this is done. I'll just copy it. Before this, let me just clean up the entire cluster. Alright, so if I do ls, I have a bunch of files here and a bunch of resources running. I'll delete all the resources by kubectl delete -f ebs deploy.yaml. So our deployment is deleted. I'll do the same with the EBS PVC. So this is deleted as well. Now I'll just delete the storage class. My bad. Alright, so the storage class is deleted as well. So now what we'll do is, I'll just delete all the files from here. Alright, so now our storage is clear, and so that we can start from the very scratch. So first of all, what I'll do is just create trust policy.json again. I'll paste our permission policy here, and now I'll create the role which will be used by the EFS add-on. I'll rename the file to trust policy.json. Okay, so it says our role is created. You can verify it from the console. Go to roles and search for EFS. You'll see this role is created, and just like the EBS role, it doesn't have any permissions yet. So we'll attach the permissions, and this permission policy is called EFS CSI driver policy. Okay, so the permission is attached. Now what we need to do is install the EFS add-on on the cluster using the role created. I'll head over to my EKS cluster. I'll head over to add-ons, and right now we have this EBS CSI driver add-on, which we just added a few minutes ago. Now I'll click on get more add-ons, and this time I'll just install Amazon EFS CSI driver. So this is selected. I'll click on next. I'll select IAM role for service accounts and select EFS CSI driver role. Click on next and click on create. So it says EFS CSI driver successfully added to the cluster. And how we can verify that? Well, just run kubectl get pods in the kube system namespace. Okay, accidentally I managed, or I happened to delete the kubectl file from here. I'll run the AWS EKS update kubeconfig file command again. Name of the cluster is going to be prod, and region is going to be AP South 1. Okay, so the context is updated. Okay, so I'll run the command again, kubectl get pods in the kube system namespace, and you will see EFS CSI controller pods running here. Okay, let's move to the next part. Now what we need to do is we have already done this part where we install the EFS. Now note down the following details to create an EFS volume which will be used for dynamic volume provisioning, and for that you need the VPC ID of the cluster and CIDR range of the VPC. And why we need this? Well, you'll understand in a bit. So if you are creating the EFS volume using the CLI command, you just need to follow the steps, but in this video I'll be doing it using AWS Management Console. So I'll just go to this part where we have to create a security group for your EFS file system. So in my EC2 console, I'll head over to security groups and I'll create a security group called EFS security group, and the VPC should be the prod VPC where my EKS cluster is running. And for the traffic, if you see the documentation, it says you should allow port 20549 from the EKS CIDR range. And what is our CIDR range for this EKS cluster? Well, you can go to the networking section, open the VPC from here, and you can copy the CIDR range from here, and add a new rule which says 2049 should be allowed from this CIDR range. Okay, we are good to go. Click on create security group. Okay, we need to provide a description here. Allows traffic from the prod EKS cluster. Click on create security group and our security group is created. Now let's move to the next part. Create an EFS file system in the same region as your EKS cluster. Okay, and how can we do that? Well, in my EC2 console, I'll head over to EFS. Okay, so we are in EFS now. Click on create file system, give it a name like EKS EFS. That's kind of funny name. And for the VPC, select the VPC where your EKS cluster is running, which is prod VPC in my case, and click on customize. Our file system should be regional. Enable automatic backups. No, we don't want it. Enable encryption of data at rest. Yeah, keep it as is. Click on additional settings. I'm looking for the section where I have to apply the security group. Okay, it's in the next page. So click on next. Here you have to select the VPC. I think the VPC is already selected, which is prod VPC. And whenever you create an EFS, you have to create mount targets. And the mount targets are always created in the subnets or the AGs. So if you are creating an EFS file system, you need mount targets, and mount targets are going to be created in the availability zones. And if you do not wish to create a mount target in the AZ, the servers which are running in that AZ won't be able to connect to the EFS. Alright, so in my case I have two AZs here, AP South 1A and AP South 1V. My mount targets are going to be created here. And for the subnets, I'll select the private subnets because my EKS worker nodes are running in private subnets. So I'll select private here and same here as well. And for the security group, I'll select the security group that we just created, which is called EFS security group. And here as well, I'll select EFS security group. Okay, seems good to me. Click on next. Click on next. Just review your settings and click on create. Okay, so EFS is in creating state. It will take a few minutes. Alright, it's already created. No need to wait for anything. If you go to network, you will see that your mount targets are in creating state. Okay, so it will take a few minutes for this mount targets to be in running state. So I'll see you in the other side of the video. Alright, so our mount targets are created. Now let's move to the next part. So I think we have already done this part where we created the EFS file system and we created the mount targets as well. Now what we need to do is we need to create a storage class for our EFS. In the same way we created a storage class for our EBS. So I'll just copy this entire script. I'll paste it here. And if you see here, we have to put the file system ID, which is gonna be the file system of your EFS file system. So I'll go to my EFS. This is my, just a second, okay, here it is. So this is my EFS file system. What I need to do is I'll just need to copy the file system ID, which is gonna be this. Just copy it and I'll replace it here. Okay, so this part is done. Keep the other things as is and copy this entire content and create a new file called storageclass.yaml. I'll just paste it here and I'll do kubectl apply -app. Okay, so it says our storage class is created. Let's move to the next part, which is to create a persistent volume claim. Okay, this claim will be used by the pods to claim storage from the EFS file system. So just copy it, create a new file called pvc.yaml, paste it here. Okay, so our persistent volume claim is created as well, and you can verify it using kubectl get pvc, and you can see this is the claim that is created. Okay, let's move to the next part and create a pod. Okay, so now what we'll do is we'll create a pod here. Deployment.yaml. Okay, it is created. Okay, instead of creating a single pod, if you see this file here, deployment.yaml, it has a kind of pod, okay, which means that it will create a single pod. What I'll do is I'll just delete this entire content and I'll paste this content here, which creates a deployment. In this way we will be able to verify whether the PVC or the persistent volume is created by execing into different pods and checking the configurations from there. So I'll just copy it and I'll paste it here, and now I'll apply this file. Okay, so it says the deployment is created. Let's see if the pods are running. Okay, they are in container creating state. Just hold on for a few seconds. The pod should be running by now. I think we did something wrong here. Let's see. Okay, they're still not running now. Let me just describe this pod and see if we misconfigure anything. All right, nothing to see here. I think we definitely misconfigured something because of which these pods are not coming up. So I'll just figure out the reason and I'll be back in a few seconds. Hey everyone, I'm back and I figured out the reason why we were getting that error and why our pods were not spinning up. So if I just do kubectl get pods, I won't see anything abnormal here, but the moment I try to describe the pod, and if I describe any of these pods, I'll see an error here, and I'm glad that this error occurred, and this way I could explain what we misconfigured here. Okay, so if you see here, it says mount volume setup failed for volume, and the reason is context deadline exceeded. So when something like this happens, it basically means our EKS nodes or the worker nodes are not able to reach the EFS file system. And the reason that is happening is because if I go to my EFS file system and if I see this mount targets here, I have this security group attached here. I'll just open this security group. So I'll go to security groups and I'll open the security group here. And if you see here, we do not have an inbound rule which allows traffic on port 2049. When we were creating the security group, I accidentally happened to add that rule to the outbound rule, okay, which is not required. So I'll just delete it and add it to the inbound. Click on edit inbound rule and just delete it. It's not needed. Go to inbound rules and allow traffic on port 2049 from the VPC of your EKS cluster, which is this in my case. So now I'll just paste it here. Click on save rules. Okay, so it says the traffic is going to be of type NFS. I'll refresh it a few times, and now I'll just check my pods. What I'll do is I'll just restart my entire deployment. Okay, so the pods have come up actually. So if you see, the pods are now in running status. Alright, and whether or not the volume is mounted, we can verify it by execing into one of the pod. So what I'll do is I'll just exec into the first pod. Alright, so I'm inside the first pod, and if you see the configurations, we are mounting the volume inside this mount path. Okay, so I'll just head over to this mount path. Alright, and right now I don't have anything here. What I'll do is I'll create a file here called index.html. Alright, so now the file exists here. What I will do now is I'll just exit out of this container and I will exec into this pod here, and I'll just verify whether this file exists or not. So I'll exit, and now I'll exec into this pod. Alright, so I'm inside the second pod now. I'll again head over to that path, and if you see, I have this file here. Although that file was created from the first pod, because it is using persistent volume, this path still exists. Alright, and the other way to verify it is by killing all your pods. So let's try that as well. So now what I'll do is I'll just restart my entire deployment. Alright, so it says the deployment is restarted, and if you see the pods here, the pods are in container creating state. Just wait for a few minutes. Now the pods are up and running, and they started just a few seconds ago, which means these are the new pods. So I'll just exec into one of them. Alright, so I'm inside the new pod. Now I'll just move to the mount path. And if you see, the file still exists because we are using persistent volume. So the data is persisting between the different pods. Although we are killing and restarting the pods, the storage still exists. It basically means we are using persistent volume. So I'll exit out of this. Alright, so we created PV and PVC and tested it with our EKS cluster. I hope you enjoyed this video. Before wrapping up, I'll suggest you to delete your cluster so that you don't get charged for it. And deleting a cluster is pretty easy. All you have to do is just go to your CloudFormation template and click on delete. But in some cases you might get an error because we have created our EFS file system. So what I'll suggest is first delete your EFS file system before deleting your cluster. So I'll just delete all my resources from here. Alright, my PVC is deleted. And I'll delete the deployment as well. Alright, so I've just deleted my resources from here. Along with this, what I'll do is I'll just delete my EFS file system, because if you remember, we did not create this EFS file system as part of our CloudFormation cluster. Rather, it was created manually. So just click on delete. Once my EFS file system is deleted, I'll continue to delete my CloudFormation template. So I hope you enjoyed this video and learned something from it, and if you did, please share it with other people, and please subscribe to the channel if you haven't already done so. I'll see you in the next video. Till then, tada, bye bye.